Hello all, this is Siva Pavan Kumar Achanta. Welcome you all to my presentation. So today in my presentation, I'm going to cover the concepts like concept of closure, what are decorators, why are they useful, how can we use them, and some examples of decorators. So coming to my first topic of this presentation, which is concept of closure. So basically, I can say the definition of a closure is like a closure is a function object that has access to variables in its lexical scope, even when the function is called outside that scope. So coming to its functionality, how it's going to work like when a nested function remembers and has access to variables in the outer function scope, even after the outer function has finished executing. So here is the example of the closure, which is defining an outer function and an inner function. Within that outer function, I'm going to add x and y here. I'm returning the inner function. So here basically I'm defining an outer function by passing an argument called x. Inside of it, there is another function defined which is called inner function by passing an argument y, which just adds x and y. So when I'm defining inner function uses a variable x which is not local to it, but however, x is available in enclosing scope that is outer function's local scope. When I'm calling inner function immediately, outer function returns the function object of inner function. So when I called outer function as closure example equals to outer function of 10, uh, it calls the inner function with by passing with the value of y equals to 5, and when inside of the inner function x is still accessible even though outer function is done executing. So it returns x plus y as 10 plus 5 equals to 15. So I'm getting the output as 15. So the note point here we have to remember is like here inner function retains access to x equals to 10 even after outer function has finished. So why the closure concept is very useful for us. So it enables us to make some data hiding and the object oriented functionality called encapsulation, and maintains state in function factories and allows function customization. So like we can able to customize the function as our requirement, and it enables us to make data hiding and encapsulation. Coming to my next concept, which is decorators. So I can say the definition of decorator as a decorator in Python is a design pattern that allows you to modify or extend the behavior of functions or methods without changing their source code. You got that, right? So decorators are built using closures and are typically applied using the like we can usually basically we can define a decorator as by starting the symbol called at. So at decorator name, and this is the basic syntax here. So this is the sample example I took to explain the decorators concept. So what's happening here is like I'm defining my decorator of func here, this decorator function that takes another function func as an argument. Inside my decorator, I'm defining a wrapper here. So wrapper is a nested function that prints a message called func is called, and calls the original function which is called func, and prints a message after that function. So what it returns? The wrapper. So the decorator returns this new function wrapper to replace the original function here. So when I called say hello function, it executes the wrapper function and gives us the output like something is happening before the function called, and the original function func called by printing a message called hello, and something is happening after the function is called. So I can summarize my above example as this decorator adds behavior before and after calling the say hello function without modifying say hello directly here. So that's the beauty of the decorators here. That's the power of decorators here. So that means like it's just wrapping an extra functionality around a function here. coming to the benefits of decorators, I can say like code reusability, separation of concerns, and I can say like drive principle. So, what is what like what is code reusability? Like wrapping a functionality around multiple functions. Simply, I can say that. And separation of concerns is like keeps core logic separate from logging, timing, some kind of things, etc., etc., like that. And drive principle is like avoids repeating similar code. So uh, we can eliminate the duplicate code using the decorators. That means avoids repeating the similar code. So I can say the common use cases of decorators is like logging, access control or authentication, caching, timing functions, input validations, like that. So how to use the decorators? Like this is the basic syntax. Like we used to start the decorator name by using at symbol defining like at decorator name, and uh, now defining a function which is going to be decorate by our decorator. So basically this one is equivalent to this single line like function to decorate equals to decorator name, and the function which is going to be decorate we can pass it as an argument. Coming to the examples of decorators, I took an example here like uh, uh, like measuring the execution time of a function. So here I'm trying to measure the execution time of this uh, timer function. Uh, so basically, this one I consider it as a great example of using decorators in Python to measure the execution of a time. So here's a quick breakdown. I'm going to explain by breaking down like how it's going to be work. So I'm defining a timer function. Inside of that, I'm defining a wrapper function, and this start equals time dot time, which record the start time, and result equals to func of this going to call the original function here, and end equals to time dot time, which records the end time, and this one prints the uh, duration, like how much time this function took. So a timer is a decorator function that wraps any function to measure its runtime, and the inner wrapper function accepts any arguments and forwards them to original function here. So when I called this flow function and I gave the time dot sleep like 2 seconds, like I can say like two turns like. This add timer line applies the decorator to slow function, and it's equal to writing like slow function equals to I can say like equals to uh, timer of I can define like this too. Like the above one is similarly works like equivalent to this one. Deleting this. So when called a slow function, will now first enter the wrapper and then time of execution and print the result. Here like finished the message of what we got, and slow function took 2.0011 seconds here. It took so and when I start. So this is the start time, this is the end time. So I'm going to differentiate between them, and I will get the answer as 2.0011. So coming to the conclusions, like so I can conclude it simply like so coming to the conclusion of a closure, functions with access to outer variables even after the outer function ends, and it enables the encapsulations as I told before. Coming to the decorators, decorators basically called functions that wrap other functions to extend or modify the behavior. Thank you so much.